Hello students, today we are going to discuss a topic that is named as Surds, and that is syllabus number E 1.18, chapter number 1, and that is a part of numbers and language, unit number 1. So an irrational radical with a rational radicand is called a surd. Now you know what are irrational numbers are and what are rational numbers are. So let's suppose we are going to write a structure that is written just below. You can see here that is nth root of a is a surd if a is rational and the result nth root of a is irrational. So what this depicts that this number is considered to be a surd when a is a rational number and the result that we will obtain after solving this part becomes an irrational number. So we have certain examples how could this be possible. We have certain numbers, like you can see square root of 3, right? Now in place of n here we have 2, but we are not supposed to write when we write square root. When we write a square root, we are not supposed to mention the 2 outside the square root, like that. This means here we have 2 is not supposed to be written. If there is a number more than 2 or another number except 2, then we are supposed to mention the value over here. So what this means, square root of 3 is when you calculate using a calculator, this will give you an irrational number. Now irrational number, what do you mean by irrational number? Means when you insert this value and get the output using a calculator, it will give you a certain line of numbers which are not in a certain pattern, or even the number will not terminate. So the number will be non-recurring and a non-terminating. So similar way, if you insert this number, it will also give you a number that is irrational. Irrational means the number is neither terminating nor recurring. So another example, that is, you can see 4 here over here. You can easily insert this value in the calculator and obtain, and this will again show the same behavior, and this one is as well. Okay, now what about this number? You can see here we have written 2 square roots over a set of numbers. So first, when you calculate the answer of this square root of 17, this will give you because 17 is a prime number, it's not a perfect square value. So when you calculate the value of this square root, it will provide you an irrational number, right? So that means this is a surd. Now we have added a number, that is 3, with this number, and again introduced a square root. Now this makes this number not a surd, right? So another value here, you can see the pi value. Pi is, you can you know that we use this value in physics usually. So pi means 22 upon 7. So that will give you, when you find the decimal value, that will give you 3.14 something, and that is continued. Okay, so but what we use, what we do in physics, that we just terminate this value or round off the value to 3.14, or we use 22 upon 7, right? So when we take again a square root on this number, this also makes this value as not a surd. So now in this part, we are going to just define the parts of this number and root of a. N is called surd index. right? So this n over written outside here is known as surd index or order of the surd, and A is called radicand, right? Or one more thing, not which is to be noted, that every surd is an irrational number. Keep in mind that every surd is an irrational number. We have mentioned here in all these examples and even in the definition. But every irrational number is not a surd. That means in this example, but when we are getting an irrational number, you cannot again convert it to another surd, because when you take a root, it will be not considered to be a surd, right? So, but every irrational number is not a surd. Okay, we will just uh, explain some solutions or simplification of surds